Achtung, welcome. Well, surely, ahoy there, my hearties. Welcome to Weird Ways of Making
Timbers.
Ship Me Timbers. Welcome to Weird Ways of Making You Talk with me, Murray and James Holland. And we are in the bowels. Well, no, it's not the bowels.
The bowels of B turret.
The bowels. Well, no, we're in A
Underneath
turret
B
now. We've
turret.
gone forward to A turret. We're below the waterline on HMS Belfast, in the most extraordinary place. If you listened to our last podcast, we talked about. From HMS Belfast, we talked about Y turret and the idea of the turret being a single self-contained unit, so an explosion would be contained across deck, so it would go vertically rather than horizontally. And we've just come down some health and safety approved ladders rather than the real thing, through a bulkhead cut in that's been cut into to allow visitors through into this. This is the most extraordinary room, Jim, isn't it?
It really is. So we've got all these tubes coming out of the, from sort of floor to ceiling of this particular area. We've got a sort of rotational ring lined with shells. We've then got wooden stacks of yet more shells, literally every which way you look. And you can see how this process would... Well, no, you can't actually. But unfortunately, we're joined by Rob Rumble and we're joined by Nigel Steele of the Imperial War Museum, who can explain exactly what happens here. Because presumably, this carousel of shells, and it actually looks almost as pretty, to be fair, goes circular in a circular motion round these tubes. But how do you get it into the tubes?
So you'd have had sailors standing inside the carousel,
right,
picking up the shells and then loading them into the hoist.
So you can lift them up. A man can lift up a 50 kilo.
Yes, yeah.
Right, of course you can, yeah.
Just about, yes. And they would be constantly rotating, and the hoists would have been constantly ticking away whilst at action stations. You'd have had other sailors standing roughly where we are now, going back to these wooden racks that you mentioned.
And adding more to the
carousel. There would have been a shell room commander down here who would have been receiving instructions as to what sort of shell to load, be it armour piercing, high explosive. Order would come in and they'd put different shells onto the carousel depending on what.
But
the
Rob,
need was.
can we move around so we can see where it is that the shells get loaded up? Is that possible? Presumably it's around here, is it? So I'm moving around. I'm moving around to starboard.
Yes, it is starboard, James. Well done. Very good. We're not far from the... Well, we're...
Just to use the right parlance.
So the only thing forward of us here is the forecastle, isn't it, basically? The rest of the ship forward of here, right?
Yeah, we're as near to the front where the forward turrets are, and just looking at now where the sailors within this carousel would have been putting the shells onto these little loading trays, and then they would have been swung into place, and you can just about see these sort of cylinders within the hoists, and you would have placed the shell perfectly in time onto the top of one of those, and that would have allowed it to continue its journey.
It's reminding me of
so these just run around, and they're so that you're effectively putting it onto a kind of a tray.
That's it. Then they're constantly running.
So
around.
it's reminding me of one of those things you stick, the internal message scoop tube things where you.
Yes.
You know what I mean?
Yes, exactly.
Sort of air pressure thing, but it's obviously not the.
It's a mechanical one.
It's mechanical.
As well.
And the idea is though that this runs like complete clockwork, and the men are part of the machine in effect, aren't they? That they're as mechanical as any of the.
That's it,
devices in here.
Exactly. We think of Belfast as being, we call it a living machine, where all 800 to 900 crewmen are there to serve the technology of the ship, be it its radar, its communications, its gunnery, its engines and boilers, all with a specific skill which they're constantly training at to perfect. And they all have their part within a much larger system, and it's the skill of the officers in charge to keep that system of manpower and machine well-oiled, both literally and figuratively, to make sure that Belfast was as potent a weapon
as she could possibly
be at a moment's notice.
But this doesn't move around with the turret, does it?
Yes, it can we see there's a steel ring within the carousel.
So all this moves,
and all of this would move
because these line up with each gun. So
yes, I was going to say.
if the guns move,
Yeah.
the hoist
This all has to move around
And
too.
you can see on the internal ring here how it all moves around. This part to this point here,
Right.
these hoists have to move in line with the guns. So if you deflect your gun that way, the hoists have to move.
We're all moving around.
So we're all shuffling around
So
to keep up
this
with
bit
them.
would stay, but this bit in the ring would move.
Got it.
So the ring moves. I always saying that if one of the things I rather fancy was taking the whole of one of the turret out, lifting that out so we could see what it looks like, and putting a giant lift shaft in the middle here, because it would make a fantastic disabled lift. You know, because when you look at the ships when they're being built, there's 4 massive holes in the ships where the turrets are going to go. Before they put the turrets in, you can actually see them on launch time. They actually come down and you can see these 4 huge big holes.
So they just get craned in and just...
They would get put in, yeah, and it's the same with the engines as well, and all the turbines.
It's a hell of a thing, isn't it? I mean, the thing that... I remember last time I was down here in Belfast, the thing that really strikes you is, this is a cruiser, this isn't even a battleship. It's freaking huge, isn't it?
Yeah.
And it's so complex. I mean, you don't doubt the complexity or the cost of building one of these when you're visiting this. The complexity of all the different component parts into it. I mean, it's so complex, isn't it? The thing that you have this technology at this time in the 1930s is just astonishing.
And I think Imperial War Museum is very conscious of how difficult it is to maintain as a fighting entity, simply because preserving it in civilian times as a visitor attraction for people to come and see. There is so much work to do. It is constant. It's like the kind of apocryphal painting of the Forth Road Bridge.
Yeah.
It is constantly painting and cleaning and maintaining and replacing and watching and making sure that everything is done properly. You can't sleep for a moment, because something always needs to be done, because particularly you have to remember that this is a vessel that floats in water.
Yes, I was just going to say it's sat in water that's eating it.
Yeah, and it rains on it, snows on it, dries it out, everything. The full range of weather and environmental factors which you would face as a ship in commission. Even though the ship isn't in commission, it still faces the same factors, because it lives in the Thames and it's exposed to all the elements outside. So,
and there's not 800 matlows on it to keep it clean and...
No, we have
after
a
it.
very restricted conservation crew who battle away with, I have to say, the superb help of many volunteers who come in and work for the Imperial War Museum, and we're very, very grateful for that at all the sites. But Belfast in particular, keeping up with this challenging task is something that we wouldn't be able to do without the volunteers, and it's a fantastic opportunity for them, I hope.
Wow. Well, I think it's absolutely amazing. Can we see the engines?
You want to see the engines? Yeah.
Yeah.
We go the engines through the boiler room, the 2 stages.
Okay.
The boiler makes the
Excellent.
steam, and then the steam drives the turbines.
Brilliant. We're going to take a very quick break, and we'll be back with the boilers. Right, well, we're walking through... Which deck are we on?
So we're on 2 deck at the moment, which is the main sort of living area for the sailors when they're off duty. We've got the mess decks, we've got the...
What have you found there, Jim? To look
Provision issue room.
the
Which
provision
is suddenly
issue room.
looking a little bit more kind of... Not Napoleonic exactly, but you know...
Prunes.
Wow.
Peas split, £14.
Peas split £14 and prunes £14.
Yeah.
The one provision that was issued from here was
Lots of trouble with
cruise
the prunes,
rum.
aren't they?
Ah, yes, the rum ration. I was going to ask you about that when we were in the shell room, because
There's a naffy as well. Look, there's a naffy.
Yeah, they could buy anything they needed. Razor blades, cigarettes, chocolate, drinks, non-alcoholic drinks, of course, except for the rum we mentioned just now.
when does the rum get doled out?
So
Milk
they-
chocolate beaties looks good.
The tradition of up spirits was midday each day, and the so we're talking about the ordinary sailors here.
Yeah.
The
Hold on, there's
the
dental
officers.
surgery. We've just gone past the dental surgery.
and the sick bay as well.
Have a
so
look at this. I mean, this is
everything you needed.
I mean, this is obviously 1960s dental surgery, but it still looked pretty good. Wooden desk, old-fashioned desk lamp. I mean, it's just incredible. I mean, it really is a floating city, isn't it? Sort of
The interesting thing
endless
about-
corridors, little rooms off them, and
With dental surgery and sick bay
Yeah.
are 2 of the parts of the ship which didn't change in the refit in the
Ah.
1950s. So this is pretty much exactly the
as it was.
configuration as it was originally built. This and the footprint of the sick bay stayed almost exactly the same. I've plotted archaeologically across the ship the changes between the 1940s ship, that I call it, and the 1960s ship, and this is one where it stays almost exactly the same.
Well, that's good to know.
Brilliant.
You wouldn't want to be doing that on a rising swell, would you?
No. Anyway, the rum. I want to talk about the booze. Jim wants to talk
sorry about
their
that.
teeth.
I can get distracted by teeth.
Go on.
And so the sailors were, this is a tradition going back to the
bakery.
18th century. When the sailors were issued their rum ration, and it lasted actually until 1970.
Yeah.
Believe it or not, when by then it was considered the technology was too advanced to risk.
Because I was just going to say, that shell room, you don't want someone who's had a gut full of rum in there, really, do you?
Well, the sailors are very proud of their traditions and very protective of them.
Right.
The rum was watered down, so it wasn't too bad. But I've tried both watered down original Navy rum and Navy rum neat as well, and I certainly would not have been able to operate a shell hoist after that. But it was just a real cherished tradition, and considering, for example, when they're out on the Arctic convoys where it's minus 20 degrees out there, and something to warm the cockles of the heart was most welcome, and the sailors appreciated the tradition. It surprised other navies. For example, during the Second World War, the US Navy was dry, and when their sailors visited Royal Navy ships and were welcomed aboard as guests and entitled to some rum themselves, they thought it was marvellous.
But on an American ship, of course, you get Coca-Cola and ice cream.
Yeah. Oh yes, it had its benefits.
But given a choice, Jim.
There was inside HMS Belfast a soda fountain where you could go and get your soda drinks and your ice cream. It was next to the library. Okay. So all comforts are thought of for the ship's company.
Brilliant. Right, let's look at the engines really quickly. Yeah. Right. Okay. So we're now in the boiler room. Two thoughts came to mind as we come down several levels. First of all, this is enormous. This is an enormous space, a huge space with this boilers. And also, up my mind, the first thing I want to ask you is, what did this ship cost? I mean, the expense.
It is mind-numbing, the complexity of this, isn't it? As we've been walking down, everywhere you look, there are pipes cladded in wadding, presumably to kind of protect people from the heat. There's so many different bits to it. I mean, the thing that strikes me is someone's designed this. Or there's a design team designing this, but I mean, it is so complex. There's, just a bit further on, there's dials everywhere. I mean, it's like something out of a kind of sort of a fantasy science fiction film or something, isn't it?
It is incredibly complex, and it's one of these things that takes a lot of study to try and even figure out how the bits all fit together, and it's taken me several months and years even to actually try and figure out what comes in where and how it all goes together. But in here, you basically get a process that's kind of classic GCSE combustion triangle, in that you get coming in, you get air, oxygen, you get water, and you get fuel to come in, which is then burnt. And that's basically, those are the three things, and put together in the right proportions is what drives the ship. Yeah. Because what you fundamentally want is coming out of this boiler is you need superheated steam, which is going to be pumped through the ship to the turbines, and the turbines are then going to turn the propellers. And so the first stage of that is coming in here, and through the ship you will see air drafts, and at the top of here there's a forced air fan which sucks air down from outside, so oxygen rich air gets pumped in to these boilers in order to create the combustion levels you need.
Well, that's interesting in itself, because people think of ships with funnels with the smoke coming out of the funnels. That's
the burning after you put the oxygen in.
The air being drawn in.
That's right. You have to suck the air in, and then at the front of here, you can see on the front of the boilers, these are basically the registers, they're the burners, so that the oil gets heated up, so that when it gets injected into inside the boilers, it can create an intense fire because it's oxygen rich. And so inside this triangular effect, this Admiralty boiler, you will find an intense fire burning, because what that fire has to do is turn the water into superheated steam, and it does it through two stages. In the top is the water tank, and it comes through the side and heats up from the fire, and it goes into the bottom here, where it's then pumped back up again and heated for a second time. And in between those levels, you then get a third element which superheats the steam, and so the water circulates through here 3 times, and then as superheated steam it gets directed out to the turbines at the back, and so it's pushed through here to an intense heat and is turned into supercharged steam.
I mean,
I'm absolutely blown away. I've been down here before, but I'm blown away. I just don't know how you get to the point where you can design this, because look at all these tubes. I mean, someone's got to go, okay, this bit goes here, this bit goes there. I mean, there are literally thousands and thousands.
Well, then design and then train men to know it inside out, so they can fix it, and just if there's a problem, they can diagnose, and repair. I mean, it's amazing. And
everywhere you look, there's dials telling you something, warning you something. It's absolutely incredible.
It's incredibly complex, but the designers and builders of the ship were skilled and proud engineers in their own right, and you are the inordinate amount of dials everywhere to monitor every single pressure or flow of water or fuel or temperatures, whatever they needed. Could say possibly over-engineered a little bit. I have spoken to one former sailor who told me, we only used a few of the dials.
Oh, really?
So, as I said, but then there's a lot of redundancies there.
There's some that mattered more than others.
There are some that matter more than others, but you could check everything if you wanted to. But as was Nigel was alluding to just now, this enormous boiler we're standing in front of is just one of 4. So Belfast had 4 screws, so that's 4 propellers in the water, each with a boiler and a turbine each. We're just in the forward boiler room here, which are the 2 central screws. There's an aft boiler room for the 2 outer screws further aft. And in terms of some statistics, you measure the power of a ship's propeller by rotational horsepower. Yeah. Each screw, Belfast had a rotational horsepower of 20,000, so that's 80,000 in total. Now, to give that 80,000 horses, to give that some perspective, a super cruise liner chugging around the Mediterranean or the Caribbean today, probably weighing 4 times as much as HMS Belfast, if not more than that, only has a power of about 30,000 rotational horsepower.
Right.
But then those sorts of ships, whilst massive, chug along very slowly. 80,000 rotational horsepower meant that when you turn the engines up full, you could get to your 32 knots in rough North Atlantic seas and hunt down those enemy German ships.
Incredible.
It really is, isn't it? It's absolutely just...
And it was the job of all of the engineering staff, so that all the way from the stokers through to the Lieutenant Commander E, who was responsible for it all, to make sure that when the captain said go, this system could work without fault. And Lieutenant Commander Darlan, who was actually in responsible for it all during the Battle of North Cape, was very proud of the fact that when he was called on to steam at these maximum revs and a maximum speed, the ship did it and reached its maximum speed for the time it took to keep pace with the Scharnhorst. And so when asked, Belfast crew responded, and all of these elements that you can see around you here are creating a fail-safe system. And so principally you might see these are the fuel pumps behind us, which are steam driven, so they take the steam from the boilers and use that to drive themselves. If they fail, then there are electrical generators, and that's why men like Larry Fursland knew it was absolutely essential that their electrical generators stayed online, because that could be a backup power. And all of these different elements and all the different dials are all charting the systems that need to come together. It's like that big machine that Rob was talking about. This is one giant machine, and everybody's part is as important as everybody else. It's essential that each individual stoker keeps his bit of the system working so that the next bit can work efficiently and function without having to stop and look behind them to make sure that it was working. They just trusted.
How did the watches or shifts down here work? So were you on, as you say, for action stations, everyone's on for as long as action stations lasts. But let's say you're sailing to cross the Bay of Biscay to Gibraltar. What
Is it 4-hour shifts?
Is it 4-hour shifts, 8-hour shifts? How does it work?
Yes, so you'd have had the 4-hour watch system, which again is a tradition dating back to the wooden earlier days, and it means that the sailors have a set routine, and this is for everyone within the ship, and it means that they know where they need to be at the right times. All of the systems on the ship are manned, and you'd have had a little nuance at the end called the dog watches, which were shorter, so that ensured that each watch was one step out each day, so that they weren't doing the same things at the same time every day.
Revolve on itself. So the dog watches are like a 2-hour watch out of the 24 that then moves the whole sort of grid on, doesn't it?
Yeah, that's it.
We're running out of time, aren't we? Actually,
We are,
Jim?
but I think we should just quickly go to look at the engine.
Right. Well, we're by the port outer engine, which is a turbine. As you said before. So this is where the steam ends up, right?
Yeah,
exactly.
exactly.
One of the places the steam ends up.
So the steam, it comes through this giant pipe that we're standing below here, and it goes around to the right of the turbine and into the system where the turbine. By now we're talking superheated steam, so it's at the highest possible atmospheric pressure that it could be, and that's enough to then spin the enormous turbine blades within the turbine, the engine itself, and those are then through a system are attached to the main prop shaft, and then there's a system of gearing between the engine and the screw, which enables you to change its speed or set to reverse or something like that. So really, other than the gearing, which is sort of separate, it's only one big moving part, which considering how big the screw shafts are about 2 feet in diameter when we get to the back of the engine, and attached to the enormous screws, which again about 20-30 feet across, and the power of these engines is just mind-boggling. And again, as we were talking about in the boiler room, all of the monitoring systems, all of the sailors working down here, making sure that their little bit was working correctly. And just behind us, on the other side, you start to see some dials where you're receiving instructions from the helmsman, for example,
full, half, slow, stop,
in the lower steering position. And as part of the wider living machine, so the instructions from the captain or the officer on the watch would go down to the forward steering position, speed, rate of screw, direction, and the speed of the engines would then be transmitted from that position back to here, and the engineers down here would acknowledge it and follow their instructions, and that's how the captain could control a ship this big as almost instantly.
Wow. Well, I mean, I'm just looking at the sort of 3 boards on the side here, collectively with about 21 dials, and they've all got things like cruising pinion forward and cruising turbine adjacent block.
So in the complex here, you've basically got 4 turbines. You can see both. So there's the low power, there's the high power turbine, there's the cruising one, and then there's the one that makes the ship go backwards. And so they're all to come together, and they're kind of 4 separate little engines, depending on how economically you actually want to steam the ship. And so those dials will allow you to control each of the turbines. And on the back, you can see the throttles. That will
Yeah.
increase the speed of the output from the turbines, and therefore the turning of the screws.
Yeah.
And then you get directions through the telegraphs coming down, so signals from the captain, from the bridge, from the wheelhouse itself, giving you, passing on all the signals direct to here as to how to actually run the engines. Because, of course, when you're in here, you can't see anything. So you're entirely dependent on orders that you receive from everybody else outside.
It's quite a thing, isn't it?
Yeah, it's amazing. I think of the noise in here, though. That's my. Again, I'm.
Noise are in the boiler room.
Yeah, yes, but still pretty good racket in here, though.
You'd have had a constant hum in here of the turbines. But you mentioned earlier how expensive is it to
Yes.
run a ship like this. That's why we've got all of these different turbines in here, the cruising turbine, for example. So, yeah, at a full pelt, the ship could make 32 knots. But if you did that sustained, you'd run out of fuel pretty quickly.
Yeah.
So 13 to 15 knots was the economic speed. And then if you could maintain that using the little cruising turbine, which used a lot less fuel, the endurance of the ship would last a lot longer.
Would they use the main turbines to get her up to a speed and then cruise on the lighter turbines?
You can then cruise on the lighter turbines.
Right, okay. So do the sort of grunt to get away with the... oh, wow, gosh, so interesting.
Yeah,
Isn't it?
Calculations and...
And the thing is with a cruiser as well, being the sort of the mid-sized ship, unlike a smaller destroyer which needed to return to port more often, a cruiser was designed to be effectively self-sustaining around the world. Its endurance meant that it could be at sea for months before having to
Call in and get
refuel and replenish and everything.
And I think as we were saying about the chase of the Scharnhorst during the Battle of North Cape, if you're on your cruising turbine and you're going along the Mediterranean through the Suez Canal, you're on your way over the Indian Ocean, on your way out to the Far East or Australia, whatever it is, that's fine. But you have to be ready so that when all of a sudden they get word that they're going to chase the Scharnhorst, they go to action stations, your engines have to be ready. And that was the moment why the Lieutenant Commander in charge of all of this during the Battle of North Cape was so pleased that the systems responded well and everything was kept as he'd kept it up to scratch, so that he could suddenly up a speed and you would go up from your kind of cruising 15 knots up to kind of 25 knots and you were ready to put the foot down on the accelerator and push the ship forward. And so you didn't know when that call was going to come. I mean, you've got an inkling if you were going into a dangerous situation as opposed to just cruising from A to B. But that's where it all comes down to the skill of the crew in getting the maximum out of the ship.
And is this the 1938 turbine or is this part of a refit?
These are the original turbines. They were refitted and changed, but they are the same configurations as far as I understand it. They're not an updated version of a modern turbine. Okay. The 3-drum boiler that we saw earlier on and the turbines that you see here were already pretty sophisticated pieces of kit.
I suppose the problem is I suppose the other problem is you can't get it out, can you?
Well, that was my next thought. Is when you're if you're refitting a ship like this, there's a limit to what you can take in and take out because they're not built in a modular style. So you take the engine out.
You take the deck off. And you remove everything above it, and then you can lift the turbines out and change them. The work like this had to be done. That's why after the mine explosion in November 1939, Belfast doesn't really come back into service until almost 3 years later, November 1942, because it takes so long to do the work, because to bend HMS Belfast's superstructure back, or the whole structure back into line, make it fit to be replated and rebuilt, you had to take the heavy parts out, otherwise it was too heavy to move. And so the ship was basically stripped out, and the turbines were lifted out for that and then put back in again, and it had to be reset on its brackets. And so basically Belfast was basically rebuilt. That's why it takes so long. And it's the same thing in the 1950s. Between 1956 and 1959, 3 years, Belfast is rebuilt. And so that's a process of refitting all this. And you can understand from standing in a space like this the complexity of the running of the ship. The other thing, as you see, is that there are similar types of mind-boggling complex areas to do with the power, the electrical power supply, which was all DC, and the fuse board for the ship, And where that runs through is absolutely astonishing. And it, again, makes you realise that the electrical complexities of this ship, so that's putting in power itself, it's putting in telephones and communications, running all of that through the ship, making sure it all keeps working, is incredibly difficult.
Yeah.
And it's a testament, I think, to the way in which a ship like this works, that it stays effective and operational. And there's a phrase in the Royal Navy that people often ask, was it a happy ship? And we're not just talking about everybody has a good time and it'll be like, a happy ship was a ship that was purred along, it was efficient, and it was run brilliantly from the top. Everybody looked to the captain, everybody respected the crew, and they all worked together. And so a happy ship was one that worked perfectly.
Yeah.
And almost
No iron team.
throughout its career, HMS Belfast was a happy ship.
Well, what a perfect moment to end on. Gentlemen, thank you so much for giving us this. I mean, we're
Yeah, it's
in
been a proper treat, isn't it?
we're in the guts of the thing here. It's just that out, but also this engine room, this turbine room, really exemplifies the complexity of the entire system, and also this idea. I mean, I'm really struck by this idea that the people in the ship are the soft bit, but they're as much the machine as the machines themselves. And without eyes to look on these dials are meaningless, and without the dials, the men have nothing to do. So it's this sort of symbiotic weapon. I mean, it's the most extraordinary thing. So,
Well, talking about the Second World War, the role of the Royal Navy was just, was just
unsurpassed, Jim.
Unsurpassed. And if you want to understand what that involved, coming here, I mean, I really would urge everyone to come and visit. It's just an extraordinary living museum in a way.
Yeah. Well,
amazing. Rob, Nigel, thank you.
Yeah, and thanks for listening, everyone.
And thank you to the Imperial War.
Yeah, and see you soon, everyone listening.